Hello everyone, it's Peter. Welcome you back. Starting from this class, I will go through the advanced Java programming. This is different from the basic Java programming. So in basic Java programming, we focus more on the language preference and the data structure algorithms like the dynamic programming, recursive, and greedy. And there are more logics in basic Java programming. But in this class, I will have more sessions for advanced Java programming. I will focus more on the OOP concept, collecting API, multi-threading, and so on. Here I give us a brief introduction of the topics. So first we will go through the Java OOP concepts. So I think in the core Java interview, they will have lots of questions for OOP concepts. And then it's collection framework. It's a group of very important API, and exception handling, file input output, lambda function, and stream. So this is now very useful in current industry, and multi-threading and concurrency. And finally, I will go through some design patterns. Actually, during the class, I will introduce other design patterns. And in the last session for the design patterns, I will focus more on the singleton pattern. Okay, now let's move to our OOP concepts. So now we will move to the object level. It's not only the language. Actually, in the basic Java programming, those things could be also available for other languages like the C, C++, C#, Python, and so on. But here, those OOP concepts here, most of them are APIs and are more on Java side. Okay. There are lots of topics. Some topics may be overlap to each other, so I may not go through all the topics in the order. So I will start with this one, reference and value. Now, here we know we learned the primitive types. Primitive types, there's only value. So like we define like int x equal to 10. So this variable x only has the value 10. It doesn't have the concept of the reference. But for object level, so they have two features called reference and value. For example, if I create an object equals to, let's say this, I use string. I think it is, we are familiar with string. String y equals to new string with new keyword ABC. Okay. So it means y is the reference of the object, which is the address in memory. I will get a bit bigger memory. And ABC is the value of the object. So here you may take some notes. I was thinking of writing a cheat sheet for Java OOP, but I think I'd better write something here for you to take your notes, because for the same concept, you don't have to recite what I write, but you need to understand it and use your own word to explain those concepts. So here, for object level, each object, like string is an object, it has two features, reference and value. The reference is this variable. This reference represents the address of the memory, and the value, like ABC, is the value of the object. So there are two different things. Then, based on this concept, reference and value, so when we discuss two objects, so for example, I want to compare two objects. So the question is, I want to compare their reference, or I want to compare their values. Or if I want to say an object is constant, we know we have a final keyword to make a constant, like final here. Yeah, so final int z equal to 5. So in basic Java programming, we already say that z cannot be changed. Z is a final variable. So z is a constant. In other words, z is a constant. It's not a variable. So z is a constant. Z cannot be changed. But what if I use a string as a final? What does that mean? Does it mean the reference cannot be changed, or does that mean the value cannot be changed? So this is the tricky part, and there are lots of interview questions related to this concept. Okay. Now to prove this, okay, let's start from the top level class. So Java top level class is object. Okay. So it means string or any other class, they are the subclass of object. So let's come back to this compiler. I say use this one. So I will show you what's the address. So suppose I have object equal to new object. Then I just print out this object equal to obj. To print out an object, by default, it will call the toString method. You can call toString, or you don't have to call toString, and it will convert to toString. Yeah. Let's execute. See, you can see, if you print out this object, there's java.long.object add this one. Okay, I copy this one. I will explain the printout. There are two parts. The first part is the type of the object. This is java.long.object. There's a package name at is at some address, and this is what? This is a hex representation, hexadecimal representation of the address. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 hex means 32-bit or is a 4 byte. Okay. So that's why in the first class in basic Java programming, I spend a lot of time to help you understand what is the binary and hexadecimal representation of data. So this is address is also a data, right? So if I move to this, this means this is 4 bytes, which is which is the same as the number of bytes of int, right? Okay, so why I say this? Because this is important. So let's come back. Let's talk about the API of object. If you search this one, this is object API. It contains 9 methods called clone, equals, finalize, get class, hash code, notify, notify all, toString, wait, wait, and wait. Wait is overloaded method. Okay, we simply say 9 methods. So we will cover all the methods in our training. Now we talk about the toString. ToString is very simple. For any object, it can convert to a string. For object level, if it's top level object, this toString will return its address. So let's run this code again. If I call dot toString, what happens? Yeah, it's the same. It converts this object to a string. So every time you can see the address is different, because every time you use the new keyword, it will create a new object on the heap. So the real address could be different. Every time you run it, it could be different. Now, another one I want to show is the hash code. So I want to have the hash code and the address hash code. And another is the reference, which is the address of the object. Reference toString. Hash code, I need to have a parenthesis. So you see, the hash code is this big number. This is integer number 4764022209, and this 1C655221 is hexadecimal. If you have interest, you can prove that this hexadecimal number, if you convert to int, it will be this int. It's the same. So it means that the address is 4 byte, so it can always convert this 4 byte address to an INT number, because the INT number also has 4 bytes. So this can be proved by yourself. I don't want to waste time here. but if you have interest, you can prove by yourself. So I just introduced two methods. Hash code of object, by default, it returns the address of the object or the reference of the object in the int value, and the toString will return the address or the reference in the hexadecimal format. That's a different format. Okay. Now this is introduced the reference value. Hopefully, based on this example, you understand that every time you talk about an object, you always need to think about there are two features: reference and value. Reference is the address, and the value is the content of the object. Okay. Now let's come back. We may spend more sessions, so there are lots of topics I want to go through one by one. Okay. This is reference values. Based on the reference values, we have another concept called immutable and final. Immutable and final. Okay. Now, let's move this. First, I give a concept. If an object is immutable, then its content cannot be changed. Content means the value, right? So, or the value cannot be changed. If an object is final, then its reference cannot be changed. Okay. So that's the concept of immutable and final. Now, to prove this, let's talk about the final. Before that, okay, let's do this. So, for example, if I say final, let me. I can define another class, class A. Let's say int value equals to 10. Now let's talk about final A. A equals to new A. Okay. So this is create an object of A. So to define a class, just a class A. Right? Give it some field. Now I print out the value plus A dot value. Just print this. Now can I change it? A dot value equals to 20. Now I run it again. Okay. See, it can be changed. Which means small a is an object, and I define it as a final object, but its content value can be changed. But what does it mean for final a? So if I call a equals to another new a, here we'll have a compile error. See, cannot assign a value to a final variable. This value actually is assigned reference, because if you call new a is create a new object and assign its reference to a variable a. So it means that the reference of a cannot be changed. You cannot assign another object to this a. After this a equals new a is only this reference. This reference cannot be changed. So this is the meaning of the final object. Now next we talk about the immutable. And we need to create. We need to discuss this issue in the in Eclipse, not in that simple online compiler, Java compiler. So in Eclipse, in our beginning session, we already talked about how to create an object, how to create a project. So we can new a Maven project. In the class, all the code I will commit to my Bitbucket and give you a link to check out. So here is next. Next. Now, group ID I can use so this dot, let's say Java. This one artifact ID is b1 dash Java. I use this one. Okay, let's say finish. So after I define this, so I right click properties, I can change the compiler to 1.8. Now in the POM, I give a good format. Okay. For the dependencies, in basic Java programming we use Java JUnit 4, but starting from this class we will apply JUnit 5. Where is JUnit 5? So you can check out this. I close this one. You can check out my Bebop comment. So it has a POM. In the POM, you can find out the JUnit 5 section. Here, JUnit 5. You copy for the JUnit 5 here. Okay. Yeah, this is JUnit 5. JUnit 5 is a little bit better than JUnit 4. So by my understanding, it has some advanced feature, has some improvement. So in the current industry, most of them already like migrate to JUnit 5. So in our current class or in the future, in like Spring, in AWS, if we want to do unit testing, we always use JUnit 5. But JUnit 5 is compatible for JUnit 4. Now, let's do this. This is JUnit 5 part. And okay. Now you can see there's an error because, as I said, there's no version, right? There's no version here. What is version? So to get a version, I give you a quick tutorial how to find the version. So you search for this artifact ID or group ID and use MVN. Okay. So there's a website called Maven repository. Go to this repository. It has this one. Right? So this is JUnit, this section API. So it's 5.8, 5.9.1. So then I use version 5.9.1. Okay. Now for ORG platform, I do the same thing. Okay. I search this. That's a platform launcher and 1.9.1. So then I add version 1.9.1. And here I copy it and save. Okay, so this test, there's some dummy code. I just remove it. This dummy code, test dummy code, I just remove it. Yeah, so then it's working. So I just demonstrated a way of if you have some dependency, there's no version, and how to find it. You can go to this website. It's MVN repository, and most of them, I cannot guarantee every of them, but most of them you can find it here. Now this is JUnit 5. Now in the properties part, so I can also introduce. If you go to this one, if in the property I can give some version, add 2 lines. Version is 1.8, and others I don't need that. I just add the 2 lines. Yeah. So during the class, if we need other dependencies, I will add it. I already introduced the Maven at the very beginning when for the environment setup class. I just make a good preparation, and then I close the POM. So I build a new package. I just say com.bebop.java.oop. So this package is only for OOP, and in the test, new package com.bebop.oop. Okay, and this one I don't need it. This one I don't need it. Okay. Now we talk about the immutable class. Let's come back. Immutable class. For the final, we already explained what is final. The reference cannot be changed, but the immutable is more complicated because immutable means that the content cannot be changed. How do we implement a immutable class? So here I give you an example. Let's say new class. Let's say immutable person. So I give a very simple one, immutable person. I give a private int ID, private int name. Okay. So usually we can create setters. This is private variable. This is the concept of OOP of encapsulation. I will give more examples of encapsulation later on. And then for this example, I can automatically generate the code. So let's source generate get and setter. Right? Usually I have this. I have a get and setter. I can get ID, I can set ID, I can get name, and I can set name. However, with this setter, so this is mutable. It means that if I create a immutable if I create a person here with ID and name, then I can use setter to change it. Then how to make it immutable is very simple. I just remove the setters. So it means in the immutable class, we only have getters. Get means read only. Right? We only have getters. We don't have setters. That's very important. We only have getters. We don't have setters. Okay. Now, after this is not enough. The reason is, if I have this one, how do I give the initial value? Because I don't have setter, right? To give initial value, I can give a constructor, immutable person. Is constructor. First, I give a default constructor, which gives the default value ID is 0, name is now. Sorry. Here I have a string name, not int. Okay. Now this is string. And to generate get and setter, generate only get, you can use another way to do that. That is, you can use the source, generate get and setter, and then you pick up getter, right? You don't have to get setter, and you say okay, so it gets same result. Then I have another constructor, immutable person int ID string name. This dot ID equals to ID, this dot name equals to name. Okay, so this is the immutable person. So this is actually, we have a pattern called immutable pattern. Maybe I write it upper side. Author. This is the comments in Java doc. Now, immutable pattern. So there are three conditions. One, all fields are private, so that you cannot access the field, so that the field cannot be accessible directly. Two, it only provides getters, no setters. The third one is it provides a constructor to initialize all values. So this is how to write an immutable class, or this is an immutable pattern. This is also a design pattern. Right. Now we can make a test. So based on this simple example, I give you a test. Now here in this test, we just say class. We don't use the other. So in this one, in this test case, it will automatically generate a JUnit4. So I don't want to use JUnit4. I just new class. I say immutable person test. Immutable person test. Okay. So I can use annotation test here. Void test. I just use test. Okay, give a name. So here you can select. You can see this is this API because I skipped JUnit 4, so there's only JUnit 5. So I write this now. I first create an immutable person. Person equals to new immutable person 1, say Alice. Okay, now how to do the assert? Oh, sorry. Actually, the same, this package name is not correct, so otherwise it will ask you to import it. Let me rename. Sorry, not this one. The package name. So to rename the package, right click, refactor, rename. Oh, it wanted to save. Okay, then this is java.oop. Okay, continue. So then you don't have the import. Then I can use assertion dot assert equals 1. Person dot get ID assertions dot assert equals the name is Alice. Person dot get name. That's it. This is a test. This is the assertions. The assert equals is a static method. If you want to skip the assertions, it's also simple. So you can use import static dot star. Then you don't have to write assertions. You can use assert equals. It's just like the JUnit 4. Okay. Then you can run it. In this test, you can run it. Yeah, it's great. So you can also use assert equals, assert true, assert false, and so on. Which is, in this part is exactly the same as JUnit 4. In JUnit 4, we don't have assertions. It doesn't mean we don't have that. If you go to our lab, so if I find any test case, for example, if I find like util, so you assert equals because the reason is, see that static org.junit.assert. So in Unit 4, you use assert. In Unit 5, you use assertions. And they also import static things. Okay, it's the same. So now I import a static with assertions. Okay, so this is about how to write immutable pattern and what's the difference between the immutable object and the final object. Okay, now let's come back. I just remove this one. So some nodes can be reviewed in our code. So in the code, I may also write some nodes. Now, after we introduce the reference and the value and the immutable and the final, and let's come back to OOP concept, like polymorphism, inheritance, encapsulation, and abstraction. This is called PIA, PIEA. So polymorphism actually is override and overload. Override and overload. I will give you an example of override and overload. Inheritance is there's a parent class, there's a subclass. Subclass can inherit parent class. So it inherits everything from the parent class. Okay. Encapsulation is like in this example, the private field is kind of encapsulation. It has those fields, but it wrapped inside. It only provides some method to access those fields. So we use private keyword to have the encapsulation. So simply saying there are two words like inheritance. Inheritance represents is a relation, and encapsulation represents has a relation. So sometimes you can see this word is or has a. For example, if class A extends B, class A extends B. So A is a child class and B is a parent class. So we can say A is a B because A inherits everything from B. But if class A has we say encapsulate a field X, we can say A has an x, right? Has an x. So for example, in this example, you can say immutable person has an ID, immutable person has a name. This is called encapsulation. It's very straightforward, easy to understand, right? It's the inheritance and the encapsulation. So abstraction, it means the abstract class and interface. We will have this topic later. This is also a very important topic. And now we talk about polymorphism. Simply saying polymorphism is one method name can have a different status. A method name, the same method can be in both the parent class or the child class. Okay? And the same method can also be in the same class with different parameters. So this is a kind of polymorphism. So it introduced the two of override and overload. Okay, so now I just use this example. Let's see. I have class A. I have method void foo. So this method, I just say, let's say hello. I can print out hello world. Now in A, I can have another method called say hello with a name. So this is called an overload. So if you compare with the say hello, both of them are say hello. They have the same return type, same method name, but different parameters. This is called overload. Overload can be in the same class. So you can print out hello plus name. This is overload. So let's make an example. Let's say A equal to new A. You can say A dot say hello, or A dot say hello Bob. Okay? Then you can run it. So hello world, hello Bob. So this is a typical overload method. And what is override? Because A by default, we know the top level class is object. Object has a toString method. So if you print out the let's see A dot toString. Okay. We know by default it is an address, it's a reference. So if I print out this one, so you can see A at this is the address. Now we can override this toString method. We can have at override. This is annotation. This is optional. You don't have to write it. String toString, and you can return a string. Say this is an object of A. Write this one. So you change it, right? Override. Override, in some sense, is a redefinition of the parent method. It's like the parent has this method, and you override this method, and you can give a different definition. Like in this example, the parent of A is object. The object has a toString method. The toString method by default, it will return the reference address in the hexadecimal code of the object. But you can override it. It gives another definition. So this is override. There's annotation. Annotation as override. Annotation. This concept was introduced in Java 5, and now annotation is used everywhere. In Spring, in Hibernate, in JPA. So in the future, everywhere we use annotation. Annotation is just a syntax. I don't want to spend much time for the annotation, and you can also define your own annotation. But most of the time, we use what is already defined. We use annotation is already defined by the API, by the library. So you don't have write override. You can comment out this code. The answer is the same. But for override annotation, I strongly suggest you to add it, because you may have some typo. For example, if you write something wrong, toString here. So you may not notice you have some typo, and if you call it, or if you just call a, and you execute, say, there's parentheses. See, this is address, and you may be confused. Say, oh, I already override toString. Why it still print out the parent toString method? The reason is you have some typo. It's not toString. So the method name or the variable name is strictly case sensitive. So if you have some typo, like with lowercase of s, then you get confused. But if you have this annotation, override, and then you execute it, it will have a compile error. Because you want to override something, you must have the same method name, but it's different. So it will show you some error. So you can fix it. Otherwise, like this kind of mistake, you may spend a lot of time, you don't know why it happens, right? So then if you do this, then that's good. So I use this example to explain what is override and overload. And this actually is the way of the polymorphism. Okay. Now, next we talk about the different types of references. So this one, in my memory, it was asked before. This is very actually in industry. If you want to understand very deep in Java, you may need to know the 4 references. But I just give a quick introduction. The 4 types of reference is called a strong reference, soft reference, weak reference, and phantom reference. I give some quick explanation. Strong reference is the reference, regular reference. So if you say A is equal to new A, this is a regular reference, which is a strong reference. And soft reference is API. So all the other 3 are APIs in Java. So soft reference means that this object is referenced, but when the memory is almost full, the memory is maybe 80% or 90% of the memory is already occupied. So the system does not have enough memory to hold a new object. Then soft reference will be garbage collected, so it will be cleaned up. And the weak reference is weaker than soft reference. It means that in the next execution of the garbage collection, it will be cleaned up immediately, no matter what's the current memory size, what's the current memory. And the phantom reference means that it does not exist at all. It does not exist at all. It means if an object is phantom referenced, it's already in the reference queue. So to understand this concept, you need to understand the garbage collection. So we talk about the garbage collection. Here I have a picture here. Garbage collection is a very, very difficult topic. I just give you a very simple introduction of garbage collection. So for garbage collection, the Java has a daemon thread called garbage collector. It will run at some time. It will never be stopped. So while your main program is running, the garbage collection is always running. So it will clean up the object which is not referenced anymore. It's lost the reference. So this garbage collection will collect those objects. So then to understand this, let's talk about the memory, the memory part. The memory has divided into 2 areas called heap and stack. Heap and stack. Heap is big, like heap can use hard drive. The size is big, but the performance is slow. And the stack is very close to the CPU, so the stack is fast. Usually, if we run some Java code, the Java code is loaded in the stack. But during the running of the Java code, it will create lots of objects. Those objects use new keyword. It will be created on the heap. So in the basic Java programming, we learned about the heap sort. So if you write the code of heap sort, so you know why we call heap. Heap is a very efficient way to store the objects, store the data, so that you can easily you can easily find it. Use the log n running time to quickly allocate this object. So this is heap. Now, for heap and stack, it also have 3 different areas for as the concept of garbage collection is called young generation, old or tenure generation, and permanent generation. Okay, what is young generation? If an object is just created, for example, like in this test, not this one. Let's talk about this test. If you create the immutable person equal to new immutable person, you use a new keyword. This object is newly created, then it will go to the young generation. If your reference is lost, for example, if I give after that I give the person equal to null, it means that this person does not point to any heap, any address. So this object will be lost reference. Then in this scenario, the garbage collection garbage collection will move the object from the young generation to the old generation or the tenure generation. Okay, and this generation has a reference queue, and they will clean up one by one in a queue concept. Okay. And there's a permanent generation. Permanent generation cannot be garbage collected. We'll talk about stream pool. Stream pool usually is on the permanent generation. Okay, that's we divide it. So the stack contains all the class level data and code. Of course, the class code will be loaded on the stack, and all the static methods. Then there is related to another topic of static and non-static. We'll talk about later. Okay, so garbage collection is a daemon thread controlled by JVM. What is daemon thread? Daemon thread. Then that's a thread. In the multi-threading, we will also come back to the daemon thread. So just this is a thread. Okay, we can use system.gc to run the garbage collector explicitly, but it is not guaranteed to run garbage collection immediately because this is a thread. Thread is not in our control. You call system.gc is just to invoke the garbage collector, but when the garbage collector will start working, it's not in your control. Okay, if an object is garbage collected, its finalize method will be invoked. So we mentioned about some Java API like object. Java, if you see the API, say we already mentioned about the toString method, right? We override this toString method. We know the hashcode method. Hashcode by default it will return the integer value of the reference of the address. Now there's a finalize method which is protected. Finalize method is called by the garbage collector on an object when garbage collector determines that there's no more reference to this object. So this is what I said. If an object is garbage collected, its finalize method will be invoked. But we usually don't touch this finalize method. It's like destructor in C++. If you have some knowledge of C++, C++ has constructor and a destructor. So you have to manually define a destructor, but in Java you don't, because there's a finalize method. It's working like a destructor. So the finalize method can be overridden for more customized cleanup. So if you want some customized cleanup, you can override the finalize method. But usually, if I override the finalize method, I just want to check how garbage collection is working. And there's some algorithm in garbage collection. I give you a link. If you have interest, you can go to the link. So here we can give an example of garbage collection, as we just mentioned. So here I knew a class called GC. Simply say GC is garbage collection demo. GC demo. Okay. Public static void. I just use main. I run it directly. So suppose I define a class. I define a class. I can define inner class. So inner class is pretty simple. I just define class inside another class. I can define, I just say private static inner class. Say my class. Okay, I just define this one. Just give a name. Give a name. Then I can override protected void finalize method. Okay, So I just print out a line. An object of my class is cleaned up. So this code, I only want to prove that when garbage collector GC is called, this object is cleaned up. So I create my class. My class is equal to new my class. Okay, and then I set this to null, means that the reference is lost. I give a reference to my class, then the reference is lost, give it to null. Null is the null pointer, right? And then I call system.gc. Okay, system.gc. Then I print out end of main. So I should know when I finished. Okay? Yeah. Because my class is never used anymore, so there's a warning, so we can skip the warning, that's fine. So let's run it. So you can see end of the main first, and then the object is my class is cleaned up. Right? So it means that if the reference is lost and you launch the GC, and this will be cleaned up. Then, but it's running after end of main. You can run many times. Yeah. First is because this is a separate thread. The thread usually is slower than your code running. Okay. This is about garbage collection. So I believe up to now, I think you should be able to answer most of the garbage collection questions, especially like the 3 areas, how it works, where does it come from. So because we mentioned about the garbage collector, then if I come back to the phantom reference, it means that if an object is phantom referenced and it is in the garbage collector queue, there's a reference queue, and this queue will be garbage collected, so you cannot reach it anymore. And the weak reference, a good example is the weak cache map. So when we talk about the collection API, I will show you an example of weak cache map to show how weak reference is working. Okay. So here is the different types of reference. I think this class can be here. I will go to the next session to cover other topics. Thank you very much.